Okay, so let me see if I can get to this real quick. So the first question that I want to get to is question number 1, and I want to talk about numbers. Okay, so I am just going to take a quick snapshot of this, and then I'll take this over to paper. I may have to sign all up. Okay, so I'm just going to say, I'll go here and call this math tutorials. You know what? No, I won't. I'll call it numbers. All right, so now open this up, and I'm just going to go ahead and add that picture in. So you guys could do the same thing here. And I want to start talking about numbers. So basically, you have natural numbers. So natural numbers are those numbers that are like, let me just write this in here. And natural numbers. So natural numbers are like 1, 2, 3, 4, 5, ... It's those kinds of numbers. It doesn't include 0, so it's essentially a set of numbers, like so. So that's your natural numbers. And then you have your integers. Your integers are going to be like ... -3, -2, -1, 0, 1, 2, and 3, ... So the 3 dots just means that they continue on in those directions. So this would be, these are our integers. And then we have rational numbers. So rational numbers are numbers that can be, that take 2 integers and form a ratio. So it looks like this. It's A over B, where A and B are integers. So if I take an example, I can take an example from up here. I can take -6. -6 is a rational number because it's 6 over 1. And a -2 over 3, oh, not 3. Where are, I don't want to put that 3 there, but I'm trying to see where is the backup. So not this one. So you have a -2 over 7. That's a rational number. 0 is rational because you can put it over 1 and you still get 0. 0.4 is rational because you can actually do like 4 over 10. Now notice what it's saying is, we say this is 4/10, but that's how you actually write it too, 4/10. And the square root of 5 is not rational. And the square root, and pi, that those two are not rational at all. Okay? So, but you do have the square root of 81 is rational because it's just 9. And you can put 9 over 1. So it's rational. That's what we mean by rational numbers and using integers to define them. And the next one, so we did natural numbers. Natural numbers again, 1, 2, 3, 4, 5, 6, 7, 8 integers. -3, -2, -1, 0, 1, 2, 3, and they both go out, they continue on. And then rational numbers. Now, irrational numbers are the numbers that are not rational, like the square root of 5 as well as pi. So 5, the square root of 5, if we put that into our calculator, and maybe I can bring that up. Let me pull this up again, and let me pull this up, and let me see if I can't find it right there. So here it is. So this is my script calculator. It is quite useful. So I'm just going to go back to paper, and then I want to pull my script calculator up here, and I can just pull it over to the left-hand side, and I should be able to, oh, nope, I can't. Oh, there we go. So if I do put the square root of 5 in here, you'll see that it's just going to be some decimal, some number with decimals that's not repeating. So you can't put it into an integer over an integer form. And then if I do like pi is just I should say pi times 1, that equals to 3.1415. So those are irrational. So that's how that goes. And let me see if I have anything else here. And then real numbers are all these numbers in this set. So all of these numbers are real. The only time you're going to have a non-real number is when you have the square root of a -1, and this is called I. So this is imaginary. Okay, so you have imaginary numbers. And imaginary numbers are different from real numbers, but when you combine them, if you have something like A plus IB, where IB is an imaginary number and A is a real number, we call this a complex number. So that's basically it when it comes to this.